Alright, welcome to unit number 6. This is going to be energy, or conservation of energy. But before we get to conservation of energy, we need to spend some time working through what is energy. Now, last unit, we spent a little bit of time talking about energy. In fact, we talked about kinetic energy. We defined it, gave an equation, and worked through some of those concepts. And we did talk about the fact that energy is the ability to do work. And that is the definition of energy. And once we get beyond that, then we're going to start taking a look about the conservation of energy and how does that play out and actually do problems with conservation of energy. To start us out in this particular unit, we're going to basically look at different forms of energy. Energy can be in a lot of different forms. And our first goal is just to identify those forms. And if we were in class, what I would have you do is right here in this word bank, I would have you work through just different forms. We brainstorm and I would write them down on the board. But since we're not in class, I'm just going to go ahead and just write those forms down real quick, and then I'll tell you what you can do with them in just a moment. So we have kinetic energy, we have chemical energy, we have just general potential energy, we have electromagnetic energy. We have up here we'll go. Whoop. We have gravitational potential energy, another form. Nuclear, mechanical energy, elastic energy, rotational, really we would put probably over here, rotational kinetic energy, sound, and then thermal. Alright, so those are, it's not an exhaustive list, but it's a good start for us. Those are just a bunch of examples of forms of energy. And let me give you these two bullets and I'll tell you what you can do with them. So the general abbreviation for potential energy is U. So when we talk about potential energy, just plain uppercase U. However, we're going to have different kinds or different forms of potential energy, and to distinguish between them, we're going to use subscripts. So like UG and that type of stuff. So we're going to use specific abbreviations. So like I said, UG universal is be like gravitational potential energy. But we'll get to those as time goes along. So what I would recommend you do is stop the tape right here and take these guys, here's your terms, and match them up to the definitions. Don't worry about the parentheses right now. Just take the terms, match them up to the definitions. There's, I think, 5 on the back side at the top of page 2. And then go ahead and resume the tape. So here we go. All right, I hope you've had a chance to match up a couple of these definitions. I'm going to go ahead and review the answers real quick, and that'll also give me a chance to talk about some of them. So first one, the energy of an object due to the position or configuration of the object. That's potential energy. And the abbreviation for it is just U. So we'll have different specific examples of potential energy, like chemical potential energy, and gravitational potential energy, nuclear potential energy. But just an overall catch-all category for potential energy is this one. All right, the next one is gravitational potential energy. I always run out of room on this one. And that's U. That's GPE is the abbreviation, and then UG, and that's the energy due to its position inside the gravitational field. So gravitational is probably your tip off there. We're going to spend a lot of time working through gravitational potential energy. Okay, the next one, energy stored in the chemical bonds of an object or material, and hopefully you picked up on the fact that that's going to be chemical energy. We're not worried about an abbreviation for that one. but I want you to make you aware of it. Energy stored inside the nucleus of an atom. Hopefully you recognize that's nuclear energy. Energy due to an object's rotation. That would be rotational. Kinetic energy. The abbreviation is RKE. We're not going to spend a lot of time on that one in this chapter, but when we get to chapter 10, we'll spend a lot of time on that one. Kinetic is the energy due to the general motion of the object, just the fact that the object is moving, and that's kinetic energy. And KE would be its abbreviation. The next one, energy due to the motion of charges. This one's a little more difficult. This is electromagnetic energy, abbreviation EM. Now, with that in mind, there are many forms of electromagnetic energy. I'm just going to list them down below just so you are at least aware of them. So when you hear these, you need to know that these are examples of electromagnetic energy. So all of them are energy, just specific examples of electromagnetic energy. So light, just the fact that you shine a flashlight, turn the lights on in a room, that's electromagnetic energy. UV, ultraviolet, is electromagnetic energy. Infrared, X-rays, if you ever gotten an X-ray before, that's electromagnetic energy. Micro waves are electromagnetic energy. This isn't all of them, but it's a good start. And then radio waves are electromagnetic energy as well. On the next page, energy due to the general random motion of molecules in an object. This one's difficult to pick up, but let me give you a little bit of a hint. If you look at my hand, if you were to take a microscope and look at my hand, you're going to notice that the molecules of my hand are in slight motion. They're in slight motion because I'm not at absolute zero. My hands have some sort of warmth, but if I rub them together and then put them on my face, oh, hey, they're warmer. And they're warmer because the molecules inside my hand are moving faster. And that's this right here. That's that general random motion of the molecules inside an object. And that would be thermal energy. So thermal energy has to do with temperature, thermal energy. Sometimes I tell my students, when you walk in this room, if you say that this room is cold, I'm not going to understand what you mean. You're going to have to say, Mr. Fisk, the molecules of this room are moving around very slowly. Would you please speed them up? And when you say that, I'll know, it's cold in this room. I need to turn on the heater. Or if you walk outside and it's really, really hot out, like we had a hot summer this summer, you could say, Mr. Fisk, boy, July, the molecules outside were moving around really, really fast, and it was very, very uncomfortable. And I'll know, hey, it must have been really hot outside. So that's thermal energy. Energy due to the motion of the molecules we move back and forth. This one's tough. But when I speak, the molecules, the air, I'll say it this way, the air inside my throat is caused to vibrate back and forth by my vocal cords. And that vibration then travels throughout the room, hits your ears, goes inside your ear, and makes the eardrum move back and forth. And you have ways inside your ear of sensing that movement. And we call that sound. So the fact that air moves back and forth, not general motion, but back and forth motion, that's sound. Sound is a form of energy. Next one, energy stored in a spring or elastic material. You probably picked this up. This is elastic potential energy, or spring potential energy. Abbreviations, EPE or SPE, US or UE. Okay, the next one, energy due to the mass of an object, and that's nuclear. You say, whoa, we had nuclear in two spots. Yeah, they're actually kind of related, but I separate them a little bit. We're going to talk near the end of this chapter about the fact that mass is actually a form of energy. If we destroy mass, we can create energy. Literally, we've destroyed mass. and we've created energy in the process. We've also destroyed energy and created mass. We can actually go both ways on that. We'll talk about that this chapter. And the last one is mechanical energy. And mechanical energy is the relative position of the interacting bodies and or their motions. So when we talk about mechanical energy, there's it's really comprised of four forms of energy. So this is kind of like a catch-all category, or you could say it's kind of like an umbrella category. It really is comprised of kinetic energy, gravitational potential energy, rotational kinetic energy, or spring potential energy. And that'll be important as we move along through the rest of the videos in this unit. Tomorrow, or the next video, we'll start with gravitational potential energy.